Okay, so this is a flipped classroom. We've done a few of these now, so you should be getting used to them. If you're watching this video at home, hopefully, and then you come to class tomorrow ready to practice the entire lesson the next day in your practice booklet and in your unit assignment. So let's get going. Today what we're going to do is we're going to simplify some rational expressions, but up until this point we've only seen multiplication and division of fractions with polynomial denominators. Now we're going to start adding and subtracting. So you'll see the addition sign there. Adding and subtracting these fractions. The first step, remember, is that you are going to factor. If you look at this thing, you notice that you can't factor anything, so you move on to your second step, and you're going to find your non-permissible values. To help yourself find your non-permissible values, you add brackets to places that you need to add brackets. So it just reminds us that those binomials are actually together. So our non-permissible values here would be n cannot equal -4 or 5. Awesome. Now we need to move into the actual simplification. And when you have addition or subtraction, simplification is a little bit more difficult than multiplication or division was. Because the only way you can combine these two fractions is if you have common denominators. When we talk about common denominators, we're talking about mixing and having these entire things. So for instance, that n plus 4, remember it's a package. So we need the other fraction to also have an n plus 4 in their denominator. So to give the other fraction n plus 4 in their denominator, we have to multiply them. So we multiply n plus 4 to the other side so that we're going to build a common denominator. And what we do to one side, we have to do to the other. Now, if we look, the other package deal that we have in the other fraction is n minus 5. And that n minus 5, we need it to show up in the other fraction. So to give the other fraction the n minus 5, we need to multiply the top and the bottom by n minus 5. You see here now we have a common denominator. We have a common denominator of n minus 5 times n plus 4. I mean, they're in different order, but multiplication in order doesn't matter. So we could rewrite this thing as 4n times n minus 5 plus 3n times n plus 4. All divided by n minus 5, n plus 4. Now that we've combined our fractions, that's like half the battle. The other half of the battle is to actually multiply these tops in, so that we get 4n squared minus 20n. And then this 3n is going to come into both sides, so we'll get plus 3n squared plus 12n, all divided by n minus 5, n minus 4. So we've multiplied everything out, and the reason we multiplied everything out was that we wanted to be able to get some like terms, and like terms that we can combine. So you see right here we have 4n squared and 3n squared. That's to add together to be 7n squared. You see we have negative 20n plus 12n. That's going to have to be negative 8n. And on the bottom, we still have n minus 5 and n minus 4. Now that there's nothing else we can do, there's no more simplifying that we can do that would help us, we're done. That's a good final answer. So we're going to try a couple more of these. It can be overwhelming the first time. First time through can be a little bit scary, so we're going to do one more together. And this is another one that's pretty simple. It's a subtraction sign this time. But subtraction signs work the same as addition signs in that the only way you can combine fractions is if you have a common denominator. So when we get to the point where we want to simplify, we're going to have to look for a common denominator. But our first step, and it's always our first step, is factor. So we're going to factor anything we can. First one can't factor at all. The second one can. The 9 minus e squared is the difference of squares. So it factors out to be that. 3 minus e, 3 plus e. The second thing we're going to do is we're going to list our non-permissible values. So our non-permissible values, I just like to write them up on the side by the question so I don't lose them, would be e cannot equal 3 or negative 3. You should have enough practice with those, you know where those come from. They came from your denominators. Next thing I'm going to do is I'm going to look at my denominators. I'm going to put brackets around everything. So I'm going to add a set of brackets on my e minus 3 there so that I remember that they're together. Right? That's a package deal. My denominators need to have that entire package. If we look, e minus 3 and 3 minus e are very, very close. The difference that they have is that they're opposite, right? The e is positive one, it's negative in the other. The 3 is negative in one of them, and it's positive in the other. So what we need to do is we need to change these symbols around. And we're going to make it a negative 3 and a positive e. And to do that, we have to change the symbol in between them. So now we have 2 over e minus 3 plus 3e divided by e minus 3, 3 plus e. And the reason we did that is now we look, and when we go to build our common denominator, it's going to be a little bit easier because this e minus 3 and this e minus 3, we already have both those things in each denominator. So we don't need to multiply the right fraction by anything because it already has an e minus 3. On the other hand, we're still missing the 3 plus e over here. So we need to multiply the top and the bottom by 3 plus e. So we are simplifying. We've got a common denominator. Our common denominator is e minus 3 times 3 plus e. Now we need to add these two fractions together. So we're going to have 3 plus e times 2 plus 3e, all divided by, and it's one fraction now, so we can combine these things together. The denominators just become 1 because they were the exact same. We're going to multiply that 2 in to try to get some like terms. So we have 6 plus 2e and plus 3e is still over there. All divided by e minus 3, 3 plus e. If you combine your like terms on the top, you end up getting 5e plus 6, all divided by e minus 3, 3 plus e. And that would be your final answer. All right, let's step it up a little bit. We're going to try a little bit of a harder one. So your steps, they still remain the same. The first step to every question you do in this unit is always factor. So we're going to factor this thing to become 5 over x minus 5, x plus 5, plus 4 over, if you do diamond method on that, you get x plus 5 times x plus 5. The second step after you factor is always write out your NPVs before you do any sort of combining or canceling of things. So our NPVs here would be x cannot equal 5 or negative 5. Because if you look at the bottom, if you had 5, then you'd be divided by 0. If you had a negative 5, then you'd be divided by 0. Now, we need a common denominator to be able to combine these things. And the common denominator on this one's kind of tricky. So the first thing we're going to do is we're going to look at the bottom of the first one, and we notice that it has an x minus 5, and the one on the right does not have an x minus 5. So we need to put the x minus 5 in there. And if you do something to the bottom, you also have to do it to the top. We then look over, and we see we have an x plus 5, an x plus 5. But you'll notice that the second fraction has a second x plus 5, which means this one should also have an second x plus 5. So we need to put in x plus 5, x plus 5. You need to have the exact same things on the bottom of both fractions and the same number of the same things. Once you have a common denominator, you can write them together. So 5x plus 5 on the top, plus 4x minus 5 on the top, all divided by, and we have x minus 5, x plus 5, and because there's two of them, instead of writing it out twice, I'm just going to say x plus 5 squared. Now on the top, we're going to distribute our numbers in so that we get some like terms and we can do some combining. So we have 5x plus 25 plus the 4 comes in, 4x minus 20, all divided by, our denominator is not changing. It's still the same thing. Your last step is going to be to combine your like terms so that you have 9x minus or plus 5, all divided by x minus 5, x plus 5 squared. That is your final answer. Three. So we're going to do the same thing, the same steps that work the same way. Your first step is always to factor. So we look at these two fractions and we start factoring things. The n minus 2 can't factor, but it can be written into brackets. And we put it in brackets just to remind ourselves that it's one thing. It's a package deal. They come together. On the bottom, we're going to get n minus 2, n minus 3. And if you need to take your time and diamond method that's okay. Minus, we have n plus 4 on the top, and we're going to put it in brackets to remind ourselves it's a package deal. It comes together. On the bottom, things that would multiply to be 30 and add to be negative 11 would be x minus 5 and x minus 6. Wonderful. Now your second step after you've factored is always to do your NPVs. So your NPVs in this case would be that, oh sorry, I started calling it x over here. These should be n's. Maybe you should always work with the letter that they gave you. That's okay. Anyway, it should be n cannot equal 2, 3, 5, 6. So we got a lot of NPVs for this question. The next thing we want to do is we want to create a common denominator. But before we create a common denominator, we're going to recognize that there's actually a simplification we can do. Notice that we have an n minus 2 here and an n minus 2 here. Because you have that, these can actually cancel each other out. Which is nice because when we go to make our common denominator, we now no longer have to worry about that n minus 2. So the fact that we got rid of that n minus 2 is actually a good thing because it makes our lives a little bit easier. Now we move on to our common denominators. And when we do our common denominator, we look to see what things are missing. So we have an n minus 3 here, which means we need n minus 3 over here. And what you do to the top, you have to do to the bottom. We then look over here, we notice that there's an n minus 5, so we need to add an n minus 5 over here. When you do the top, you do the bottom. We also notice there's an n minus 6 that's missing, so we need one in this fraction, n minus 6, n minus 6. Now we see we have a common denominator, right? Everything that's in the bottom on one is on the bottom on the other. So that means we can rewrite this as one big fraction. So we have n minus 6 times n minus 5 minus n plus 4 n minus 3 all divided by n minus 3 n minus 5 n minus 6. Along the top, we're going to simplify, right? So we're going to multiply these things together, expand them out so that we can collect any like terms. You're going to do FOIL, right? So first, outside, inside, last. And you're going to get n squared minus 11n plus 30. I did that pretty quick. If you need to take an extra step or do it on scrap paper, that's okay. The other one's going to become minus. And I'm going to put it in brackets because that minus needs to apply into all three things I get from when I FOIL it. So plus n and then minus 12. All divided by n minus 3, n minus 5, n minus 6. Now if you're looking at the top, this minus sign, we want to make it a positive, but that changes all the other symbols. Once you've done that, then you can combine your like terms. So my n squared minus n squared, they're going to cancel each other out. My negative 11 minus n will give me negative 12n. My 30 plus 12 will give me plus 42. And it's all divided by our mammoth thing, n minus 3, n minus 5, n plus 6. Sorry, minus 6, not sure why I said plus. And that would be our answer. So just a quick review. First step is always factor. Second step is always NPVs. Third step is find a common denominator. Fourth step is combine them. And your last step is to multiply them together and collect like terms on the top, which we've done. All right, our last question. And this is going to be by far our hardest question. So this is a very top, high-end level question, very difficult. It's supposed to be difficult. The question we did before this, even that's a pretty difficult question. It should be expected that you could do it by the end of the unit, but it's not nearly as difficult as this question we're about to do here. So let's take a look at it. We notice that we have three fractions here. Right? We have 1, 2, 3. The first two fractions are multiplied together, and the next fraction is subtracted. So we're going to do BEDMAS, and we're going to multiply the first two fractions together, because that's what you would do. But your steps don't change, so don't let a question that's this huge intimidate you. We're going to tackle it the same way we would tackle any question. And the first step is always going to be factor. And you should notice right away that there's some GCFs that can come out. And I'm just going to sketch them in here quickly because I'm writing big. And when I write big, I run out of room fast. So I can take a 2 out on the top and a 3 out on the bottom, and then I can factor those things diamond. So when I factor them diamond style, I get 2 bracket. I'm going to get things that multiply to be 7 and add to be 8. be x plus 7 and x plus 1. On the bottom, we're going to get 3, and then things that multiply to be 9 and add to be 10 are going to be x plus, sorry, I shouldn't double bracket it. Be x plus 9, x plus 1. So that's the very first fraction factor. The second fraction factor is going to be x. Things that multiply to be negative 18 and add to be 7 would be x plus 9, x minus 2. On the bottom, things that multiply to be negative 21 and add to be 4. We're going to get x minus 7, x plus 3. And we're even going to factor the next one over. So that factors to be x squared on the top, but on the bottom we're going to get x plus 4x minus 3. So if you need to take your time a little bit more on that factoring, that's okay. I'm pretty good at factoring. I've been doing this for a long time, so I can do it in my head pretty quick. But if you have to write out all those factors on a separate piece of paper, that's okay. Take your time. That's all right. Once I do that, I'm going to remember our tricks from our multiplication. And our tricks from our multiplication of fractions said that anything that's on the top and on the bottom can be canceled out. So our x plus 1 and our x plus 1, they can be canceled out. But they're not the only things that can be canceled out. The other things that can be canceled out are our x plus 9s and our x plus 9s. And I hope by now that you figured out that I made a little bit of a typo. So these bottom fractions, I factored them incorrectly. It should have been x plus 7 and x minus 3. Hopefully I said that in the video and just wrote the wrong thing. So then I noticed that the x plus 7 and the x plus 7 can also be canceled out. So that's really nice. Like, I mean, we got a lot of things canceling out. Once you've done all your canceling when you're multiplying fractions, remember that you can just combine the tops and combine the bottoms. So it now becomes 2x minus 2. Because those were the two things that were left over on the top. The two things that were left over on the bottom were 3 and then x minus 3. You then need to subtract your other fraction. And now you notice that this question, which was once very daunting and very big, is now a simple addition or subtraction problem where we need to get our common denominator. If we want a common denominator, we're looking at all the things that we see in one, and we make sure it's in the other. So for instance, there's a 3 over here in this one, which means there should be a 3 over here in the other one. So we multiply the top and the bottom by 3. We notice there's an x minus 3 over here in this one. There's also an x minus 3 over here in that one, so that's okay. We then notice there's an x plus 4 on this one, which means we need an x plus 4 on this one. And now we have a common denominator. Both fractions have the same denominator. They have 3 times x minus 3 times x plus 4. We write this as one massive thing now. So we have 2x minus 2, x plus 4, minus 3x squared, all divided by 3x plus 4, x minus 3. Your last step here is going to be to multiply these things together. Just going to lift this up a little bit. Let's have some room. So you're going to multiply your tops together. I can't move those words, but that's okay. So I'm going to multiply these tops together. I'm going to FOIL them. And I'm going to get 2 and then x squared plus 2x minus 8 minus 3x squared, all divided by 3x plus 4, x minus 3. I'm then going to multiply the 2 into the brackets. So I'm going to have 2x squared plus 4x. Minus 16 minus 3x squared, still sitting there, all divided by 3x plus 4, x minus 3. And our final step here is going to be to combine our like terms. So we have the 2x squared and the negative 3x squared. Those can be combined to be negative x squared. And since I'm running out of space, I'm just going to combine them and write it out. Well, I'll have it over here. So it equals negative x squared plus 4x minus 16, all divided by 3x plus 4, x minus 3. That would be your final answer. That's a lot of work. That's a tough question. You have to know a lot of things. You have to remember how to multiply your fractions. Then you have to remember how to subtract your fractions. And in fact, we missed a step in here. And I hope that maybe you caught it. We forgot to list our NPVs. When you list your NPVs, you do it after you factored, before you canceled anything out. So the best time to list our NPVs would have been during this step right here. And just for the record, they would have been x cannot equal negative 9, negative 1, negative 7, 3, or negative 4. So just for the record, we should have written those out. I got a little excited and carried away with multiplying our expressions, so I just started going. Okay, that does it for our flipped class. Hopefully you come to class ready to practice. Maybe you need to review the video one more time, watch a couple more examples, but you'll get all day in class to practice your skills.